Good afternoon. We are going to go through lesson 2.2e. If a line does not go through the origin, it does not have a constant proportionality. However, it still has a constant rate of change or slope. A translation is another type of transformation that relates a proportional relationship to a non-proportional relationship. Shifting a line or moving all the points on the same line, distance, and direction is a translation. Okay, so we're saying, hey, if it's proportional, it goes to the origin. If it's not proportional, then it doesn't go through the origin, which means it was a slide from something that was proportional. So translation means to slide. All right, use the equation to complete the following. Make a table of values for the equation y equals 1/2 x and graph the equation. Now I could put in 0, 1, 2, 3, but I've got a fraction. It's easier if I go with multiples of that denominator. So the denominator is 2, so I'm going to go with 0, 2, 4, 6. That's easier to take half of. So half of 0 is 0, and half of 2 is 1, and half of 4 is 2, and half of 6 is 3. Okay, so I can use my table to plot the points, or I can look at the equation. I know that it goes through the origin. I know that its slope is 1/2. So every time I go up 1, I got to go over 2. Up 1 over 2. Just need enough to make a line that you're comfortable with drawing. And then we got to take our line and take it all the way through the graph. On the same coordinate plane, translate every point 3 units up. Then draw the new graph in a different color. So we're just adding 3. So our new one, if we look at the table, we're going to add 3. So 3, 4, 5, 6. We're shifting our graph up 3. The y-intercept is now 3. It's parallel. It's still going to have a slope of 1/2. And then we make a line. Excuse my voice. You can see that I'm not completely healthy yet. And that I think I can't count. I can't count. What did I do? I went off on this point over here. There we go. And we made a parallel line. It shifted up 3. Remember, all we did is we changed that y-intercept from 0 to 3. So our equation, we didn't change the slope. We just changed the y-intercept. So y equals 1/2 x plus 3. Okay? It's translated 3 units up. Okay, remember it's a video, so if you need a pause, hit pause. Or rewind or whatever. All right, next part. The general form of any linear equation is y equals mx plus b, where m represents the slope or the rate of change, and b is the initial value or y-intercept. This form is called slope-intercept form of a linear equation. In the previous example, the equation y equals 1/2 x plus 3 represents a linear relationship with a slope of 1/2 and a y-intercept of 3. Compare and contrast the two equations using the Venn diagram below. Okay, so a lot of important stuff there. We have this format. There's different formats of a line. This is one format we're going to use. Okay, m is the slope. It's how you move. B is the y-intercept. It's where you begin. Okay, so I look at these two. I see they have the same slope, but if I put plus 0 here, plus 0. They have different y-intercepts. Okay, so pause the video and you try number 3. All right, this was an integer value, so I'm just going to go with my easy points. 0, 1, 2, 3. 0 times 4 is 0. 0 times 1 is 4. 2 times 4 is 8. 3 times 4 is 12. Okay, so I'm graphing my first one. I know it has a y-intercept of 0. It has a slope of 4, so it goes up 4 over 1, up 4 over 1. I get enough points to where I'm comfortable graphing that line. Okay, my next one, I'm shifting up 5. So I'm adding 5 to all my values. 5, 9, 13, and add 5, 17. And I should have labeled it over here. Let's go back. Y equals 1/2 x. Y equals 1/2 x plus 3. Okay. So this one is y equals 4x. Now we want to shift up 5. So what does shifting up 5 do? It's changing that y-intercept. It's going up 5. It's not changing the slope. It's just changing the y-intercept. So I'm starting at 5 and going up 4 over 1, or down 4, left 1, same thing. And I see I'm going to form parallel lines. How does the graph relate to your new? How does the graph of the new equation? I'm going to write the equation. Okay, here we go. Y equals 4x plus 5. How does the graph of the new equation relate to the graph of y equals 4x plus 4? It is shifted, translated, up 5 units. And I need to make sure I'm labeling my graph. Y equals 4x plus 5. All right, y equals negative 3x. We're going to have a negative slope, so we're pointing the other direction. Okay, that's an integer, so let's go with my values. 0, 1, 2, 3. 0 times negative 3 is 0. Negative 3, negative 6, negative 9. I know I have a y-intercept of 0. And I have a slope of negative 3. I'm going down 3, right 1. Down 3, right 1. That's the same as going up and left. Okay, now we want to shift 7 units down. So at the end of our equation, we're going to be subtracting instead of adding. New line, we're dropping it by 7, -7, -10, -13, -16. So our y-intercept is at -7, same slope, down 3, right 1. Or up 3, left 1. hate. I hate that. Y equals negative 3x minus 7. How does the graph of your new equation relate to that graph? It is translated 3 units down. Nope, not 3 units, 7 units down. Now you're probably wondering, can't you shift left and right? Yes, you can, but it's harder to write the equation that way. How do you know if relationship is proportional based on the equation? It will have no addition at the end. How do you know if it's non-proportional? There will be a constant at the end. How are the equations y equals mx and y equals mx plus b related to each other? They have the same slope, but different y-intercepts. Y equals mx plus b is translated b units up from y equals mx. Okay, so m is how you move, it's the slope. B is the y-intercept, it's where you start. Is it linear? Yes. Is it proportional? Yes, because here, there's no b, there's no y-intercept. All right, a whole bunch of copying, here we go. M is still a slope. That's how you move. B is the y-intercept. It's where you begin. Is this linear? Yes. Is it proportional? No. B is not true. Okay, hit save and turn in.